एक वक्त था जब लाइफ सिंपल थी, छोटी सी प्रॉब्लम आती थी और हम गूगल कर लिया करते थे।
फिर टीपी का क्वेश्चन पेपर आया और हमारे सपने ने रेजिग्नेशन दे दिया। लोग कहते हैं ना, डोंट पैनिक, पर जब क्वेश्चन में 5 अननोन हो और एक भी फॉर्मूला याद ना आए तो सिर्फ एक ही सॉल्यूशन बचता है।
अरे हे भाई, या तो वीडियो बना ले या तो सॉल्व कर ले।
हेलो गाइस, वेलकम टू आवर यूट्यूब चैनल टीपी की पढ़ाई। आज के इस पॉडकास्ट में हमारे साथ हैं अन्ना विकास रेड्डी जी। सॉरी
मारा जाएगा।
सॉरी, ये पूरी गलती हमारे एडिटर की है। विकास जी से हम माफी चाहते हैं। सो लेट्स बिगिन आवर पॉडकास्ट। Our today's podcast is about how we can find friction factor in a packed bed column. But first of all, to let our viewers know, Vikas ji, what is a packed bed column?
ऐसा होता है कि packed bed column is a long vertical tall vessel in which solid material like racing rings are filled, which increases the surface area of that packing. So packed bed column is used in various processes like absorption, distillation, stripping, and various industries like petrochemical, chemical, pharmaceutical, etc., etc. So that is what is I know much about that packed bed column.
विकास जी, हम आपसे रिक्वेस्ट करते हैं अगर आप अपनी थोड़ी एक्सेंट ठीक कर दें, क्योंकि और मैक्सिमम व्यूअर्स आर फ्रॉम यूपी, बिहार एंड महाराष्ट्र।
Sorry, I will try to speak normally. Will try.
So आगे बढ़ते हैं हमारे पॉडकास्ट में। Why is it necessary to find friction factor in a packed bed column? Why are we doing it, Vikas ji?
So friction factor is very important because from the friction factor we know about that pumping capacity, pumping cost, because the more the friction, the more is the pressure drop. The more pressure drop, the more pumping will be required. So the pumping cost and pumping characteristic will be defined by the friction factor. So it is very important to know the friction factor so that we can choose our pump and their costing about.
The most important question of our podcast will be, how do we find friction factor in a packed bed column? As of I know, जैसा जितना मैंने टीपी में पढ़ा है विकास जी, कि the friction factor greatly depends on the Reynolds number. If the fluid is in laminar region, then we use Blake-Kozny equation. If the fluid is in turbulent region, we use Plummer equation. And if the fluid is in transition phase, we superimpose both the equation and we get another equation which can be further modified and converted to other dimensionless form to give a equation which is very popular equation and is known as Argon equation. But to simplify it for our viewers and students, let them know which equation should they use for finding friction factor in a packed bed column.
So basically we study all types of flows in books like laminar, turbulent and transient, but most of the processes in our industries are mostly in the transient phase or it can be in the turbulent phase. So for that we use Argon equation for determining the friction coefficient and the pressure drop across the packed bed column.
So और सिंपली हमारे यूजर्स को समझ में आएगा।
So here is the question to find the friction factor for the packed bed column. So let's see the question. The air is flowing through a packed bed of spheres having a diameter of 12.7 mm. Void fraction of bed is 0.38. Bed diameter is 0.61 meters. Bed height is 2.4 mm. Airflow rate is 0.358 kg per second. Density of air is 1.221 kg per meter cube. Viscosity of air is 1.9 into 10 to the power minus 5 pascal second. And we have to calculate the friction factor and the pressure drop across the bed. So let's first draw the packed bed column. So as given, this is a packed bed where the packing materials is of spheres. So we will draw the spheres. So let's note down the values given. The void fraction of the bed is 0.38. Void fraction is the space left after that packing. There is some space is left after the packing material is inserted in the column. 0.38 void fraction means 38% of the column is vacant. So bed diameter is given as 0.61 meter. This is 0.61 meter. Bed height is this. Airflow rate is given. Density of air we call as 1.221 kg per meter cube. Mu of air is given as 1.9 into 10 to the power minus 3 Pascal second. So let's calculate the friction factor for the packed bed.
The first step in solving any packed bed question is first to find Reynolds number. So I hope you have noted down the question. Now let's proceed with the solution. So first we will find the Reynolds number, and the formula for Reynolds number is so here dp is the diameter of the particle, v0 is the velocity of the air, rho is the density, this epsilon symbol represents the void fraction, and mu is the viscosity. But in this question the velocity of air is not given. We have given the mass air, the mass velocity of the air. So we will convert this equation into a form which contains mass velocity. So we know that if we multiply velocity into density, we get mass velocity, and mass velocity is mass flow rate of air upon cross sectional area of bed. The mass flow rate of air is given in the question, which is 0.358 kg per second. Cross sectional area is also given. No, diameter of the bed is given, so we can find the cross sectional area of the bed, which is pi by 4 . Now we will put this cross sectional area value into this formula and we will get mass velocity of air. This value comes out to be 1.1225 kg per meter square second. Now this Reynolds number formula transforms into dp g upon 1 minus void fraction mu, where g is the mass velocity of air, which we have just calculated. Now we will know all the values. dp is given in the question, g we have calculated here, epsilon is given in the question, and viscosity of air is also given in the question. So now let's calculate Reynolds number. Diameter of the particle is given 0.0127 meter. Mass velocity we have just calculated the value comes out to be 1.225 upon void fraction was given 0.38 and the viscosity of air given is 1.9 into 10 to the power minus 5 Pascal second. So this value of Reynolds number comes out 1321. Now, as we have discussed earlier, that the friction factor greatly depends on the value of Reynolds number, whether our flow is in turbulent region or transition region or laminar region. Here we can see that the flow is in turbulent region as Reynolds number is greater than 1000. So we can use the Ergun equation for finding the friction factor. So the general Ergun equation is given as this is the general Ergun equation where Fp is the friction factor, delta P is the pressure drop across the bed, L is the length of the bed, dP is the diameter of the particle, rho is the viscosity, and V here is air velocity. Now again, here air velocity is not given and we have to use mass velocity because that is what we have calculated. So what we can do here is we can multiply by rho and also divide by rho. So this term will become g square, and g value we have calculated already. Epsilon is given. This Rep is the Reynolds number of particle which we have already calculated. So now let's calculate friction factor for the given problem. You can put we will put the Reynolds number value in this term and get the friction factor. So the friction factor comes out to be 150 divided by So if you put all the values in the calculator, you will get 1.8635. This is the friction factor value. Now to calculate the pressure drop across the column, you can put either of the values into this equation to find the pressure drop. Friction factor value we have already calculated, so we can put it here 1.8365. Now all the values are known, so we can put in this equation and calculate the pressure drop. The diameter of the particle is 0.0127 meter. Density is given as 1.221 kg per meter cube. Void fraction is 0.38 cube divided by the length of the pack bed, which is 2.44 meter, multiplied by G that we have just calculated. The value of G is 1.1225 square into 1 minus epsilon, and if you put all these values correctly into the calculator, you will get the value of delta P. You will get the value of delta P as 0.04 97 into 10 to the power 5 Pascal or 4.97 kilopascal. So this is our final answer where we have calculated the pressure drop across the packed column. Now there can be variations into the questions also, like there is the mixture of particles where it is given that their size ratio is given. There you have to use, instead of dp, you will use mean surface diameter. So with this we end our topic. Thank you.